The question of whether the interstellar object 3I/Atlas is merely a comet or something far more complex has captured the imagination of millions, igniting debates across scientific forums, social media, and fringe theory communities alike. The idea that a mysterious object entering our solar system from the vast uncharted reaches of interstellar space could be a technological construct or even an extraterrestrial craft feels like the plot of a science fiction epic. But the more we learn about 3I/Atlas, the harder it becomes to dismiss these whispers outright. Articles, videos, and discussions have gone viral, with many people wondering whether the strange anomalies observed in its behavior hint at something deeply unusual, perhaps even revolutionary. And as the world watches, experts like Harvard astrophysicist Avi Loeb continue to highlight details that challenge the object's classification as a typical icy wanderer. NASA and the European Space Agency are tracking the object with intense precision as it streaks past Mars and moves toward the Sun, further fueling speculation that this encounter could reshape our understanding of what is truly possible in the cosmos. On October 21, 2025, a rare and dramatic cosmic moment will unfold, one that has astronomers simultaneously thrilled and frustrated. This is the day 3I/Atlas moves into perfect alignment on the far side of the Sun, placing it in what is known as a solar conjunction. For observers on Earth, the Sun's overwhelming glare will mask the entire region behind it, rendering the interstellar traveler completely invisible. Telescopes will be unable to track its motion. Instruments will be blinded by radiation and overwhelmed by the sheer brightness of our star. For several critical weeks, this mysterious object will vanish from our view, hiding in a zone where human eyes and machines cannot follow. It is a disappearance imposed by celestial geometry, a predictable side effect of orbital motion, yet the timing could not be more unsettling. The idea that an interstellar object becomes completely unobservable during the exact period when a spacecraft would most logically choose to conduct a complex maneuver is, for many, a coincidence too large to ignore. This retreat into the Sun's shadow raises a provocative question. Is this alignment simply the natural outcome of orbital dynamics, or is it, entirely hypothetically, a deliberate exploitation of physics by something intelligent? Science does not require us to assume extraordinary explanations, but it does compel us to take note of extraordinary circumstances. And one of the most fundamental principles in astronautics, the Oberth effect, sits squarely at the center of this discussion. The Oberth maneuver or Oberth effect describes a phenomenon in which a spacecraft gains far more energy from its engine burn if that burn occurs at its highest speed, usually at a close pass to a massive object, such as a star or planet. When a vehicle accelerates at perihelion, where gravitational forces have pulled it into its fastest motion, it can use that velocity to multiply the efficiency of its engines. In simple terms, firing a rocket when moving quickly gives you a much greater bang for your buck than firing it while moving slowly. This is not theoretical. It is a practical and widely accepted tool in mission planning. Human-made craft like Voyager, Cassini, and the Parker Solar Probe rely on gravitational assists and strategic perihelion maneuvers to maximize their momentum without wasting fuel. If 3I/Atlas were not just a comet, if it were instead an engineered vessel, this would be the exact moment when it would choose to carry out a major burn, a course correction, or even the deployment of probes. It would maximize thrust efficiency, conserve precious energy reserves, and alter its trajectory in the most effective way possible. And the Sun's blinding position would conveniently ensure that every action taken would remain completely hidden from the prying eyes of human instruments. For those who already suspect something unusual about the object's behavior, this convergence of physics and invisibility feels almost scripted. The alignment becomes even more intriguing when we consider what happens next. Only 8 days after it disappears behind the Sun, just long enough for something concealed to potentially take place, 3I/Atlas will reach perihelion on October 29, 2025. At this moment, it will hit its maximum velocity, racing faster than at any other point in its journey. This is the most energy-efficient window for an Oberth maneuver. It is the most logical moment for a spacecraft to change course. And perhaps most unsettling of all, it happens while the object is still shielded from view by the sun's overwhelming brightness. Astronomers call this a coincidence, but even they admit it is remarkable. Scientists who study orbital design emphasize that if someone or something were creating a deliberate path through the solar system, they could hardly choose better timing. The sun becomes both an engine and a cloak, offering power and secrecy in the same moment. Human spacecraft designers dream of such opportunities. Hypothetical extraterrestrial navigators would undoubtedly recognize their value. This leads us back to the haunting question asked in the source material. Is this perfect alignment, this narrow window of invisibility combined with gravitational advantage, truly just a product of random natural motion? Or is it the signature of deliberate design, a maneuver planned with precision on a scale far beyond our current technological capability? Most scientists maintain that natural explanations are more likely. Comets often follow peculiar paths. Interstellar debris arrives on trajectories we are only beginning to catalog. But even within the scientific community, there is growing recognition that the universe is stranger than we once believed. The discovery of Oumuamua in 2017, another interstellar object with bizarre, non-comet-like behavior, opened the door to discussions previously avoided for fear of ridicule. Its acceleration without outgassing, its strange cigar-like shape, and its mysterious tumbling motion still remain unexplained. 3I/Atlas appears to present its own list of anomalies, which is why so many people have become captivated by the possibility that we may again be witnessing something unprecedented. The viral theories about an alien ship hiding behind the sun are exaggerated, but they emerge from the same set of facts that legitimately puzzle astrophysicists. Interstellar objects do not behave like the icy comets we see from our own solar system. They are formed under conditions utterly foreign to us, shaped by stars we will never visit. Their chemistry, structure, and motion defy our expectations simply because they come from environments we do not yet understand. So even without invoking intelligence or engineering, 3I/Atlas remains an object of extraordinary curiosity. And yet, the timing of its conjunction and perihelion remains eerily compelling. The fact that observers are forced to watch helplessly as it slips into a region of space where any hypothetical technological activity cannot be directly witnessed only fuels the fascination. It is the perfect recipe for mystery. A foreign object from another star, a sudden disappearance behind the sun, a moment of maximum potential energy, and a world waiting in suspense for its reemergence. Whether 3I/Atlas is simply a comet following a natural path or something far more extraordinary remains unknown. But what is certain is that this event has sparked a global conversation about our place in the universe, the limits of our technology, and the possibility that we may not be alone. The cosmos has always hidden secrets behind its brightest light, and for a short period in October 2025, one of the strangest objects we have ever seen will pass through that veil. When it emerges, we may find that nothing has changed, or we may discover that everything has.